exploring the mysteries of dark matter. Introduction. Before we get into too much detail, let's firstly explain what dark matter is. To begin with, dark matter has no true definition until this point. However, hypothetically speaking, it is a form of matter that does not interact with light or electromagnetic fields. A fun way to understand this is by imagining it as the universe's unseen ninja. Even though it's invisible, it controls the cosmic dance by pulling gravitational strings and making galaxies spin mysteriously. Right now, scientists are on a mission to find out the VIP's secrets and show them to the cosmic spotlight. Why it's important to know about dark matter. Understanding dark matter is crucial for unraveling the mysteries of the universe on both small and large scales. On a galactic scale, dark matter is required to explain the known rotating speeds of galaxies as it provides the gravitational glue that keeps them from flying away. Dark matter is also an unseen factor that shapes the universe's structure, influencing on how galaxies come together in groups and connect across the universe, forming what is known as the cosmic web. Additionally, dark matter leaves an impression on the cosmic microwave background radiation, which is the only piece of evidence that proves the theory of the Big Bang. With this impression, it can help us figure out about the universe's early condition and its underlying nature of how the universe truly evolved. Historical discoveries leading to dark matter. Dark matter story starts in the 1930s with Fritz Zwicky, who noticed something strange in galaxy clusters. Imagine he put them on a galactic scale and they weren't holding hands as they should. So he coined the term dark matter to explain the gravitational weirdness. Fast forward to the 1970s, we have Vera Rubin adding more pieces to the puzzle. She discovered that galaxies were spinning like they're playing an interstellar game of Twister. An invisible dark matter seemed to be the one calling the shots. As we hit the 80s and 90s, astronomers uncovered a universe sized spiderweb crafted by dark matter. In 2006, the Bullet Cluster revelation was like finding a secret passage in the cosmic library, as it revealed dark matter moving during the collision between groups of galaxies. Now, scientists are still on the hunt, trying to catch a glimpse of those mysterious dark matter particles in the particle physics laboratory. Evidence to prove dark matter exists. Galaxies spin too fast based on visible matter alone, suggesting unseen mass, dark matter, is at play. Patterns in the CMBR align with predictions involving dark matter gravitational influence. The cosmic web of galaxy distribution implies the gravitational presence of dark matter. The separation of visible matter and gravitational effects during collisions supports dark matter's existence. Extensions to the Standard Model introduce new particles potentially serving as dark matter particles. Relation between wave particle duality and dark matter. Wave particle duality, a key concept in quantum physics, states that particles, including supposed dark matter particles, can behave in both wave like and particle like ways. Although this situation is not directly detected in dark matter, it is relevant when considering the quantum nature of dark matter particles. Many dark matter particles might act like waves, influencing how they spread out and interact across the entire universe. This duality is especially important in investigations aimed at detecting dark matter, where principles such as interference patterns and quantum tunneling are used to examine potential signals associated with these particles. The broader context of quantum physics, including wave particle duality, is critical for understanding the potential quantum characteristics of dark matter. Challenges in detecting dark matter. Detecting dark matter is challenging due to its invisible nature, weak interactions, and unknown properties. Traditional optical methods are ineffective because dark matter doesn't emit or reflect light. Detecting dark matter directly is challenging due to its weak interaction with ordinary matter and the extensive range of potential characteristics it may have. Background noise from cosmic sources and Earth's atmosphere adds complexity, making it difficult to distinguish dark matter signals from other astrophysical processes. Finding dark matter is more difficult since there are so many theories about what it could be. and its signals are believed to be very faint, complicating the search. Scientists are currently doing experiments and coming up with new theories to deal with these challenges and try to understand more about dark matter. Role of dark matter in galaxy formation. Dark matter, the mysterious architect of the universe, pulling invisible strings to shape galaxies and weave the cosmic web. Though it cannot be seen, its gravitational coordination directs the display we identify as the cosmos. Dark matter forms an invisible region around galaxies, a gravitational embrace holding stars and gas. It's the cosmic seed luring matter to create galaxies. But the adventure doesn't end there. Dark matter's influence extends to the vast cosmic web, a cosmic connection where galaxies find their place. Imagine unseen forces guiding galactic collisions, sculpting the universe's evolution. In this cosmic tale, the dark matter is the unseen maestro composing the symphony of the universe. The role of light in understanding dark matter. Light interacts with dark matter primarily through gravitational lensing, where the gravitational field of dark matter bends the path of light. This phenomenon distorts the appearance of distant galaxies, creating multiple images and helping astronomers map the distribution of dark matter. Additionally, light from the cosmic microwave background and observations of galactic rotation curves contribute to our understanding of dark matter's presence and influence on cosmic structures. While dark matter itself doesn't emit or absorb light, its gravitational effects on light provide valuable insights into the invisible structure shaping the visible universe. Potential dark matter particles. Weakly interacting massive particles, short for WIMPs, are hypothetical particles that are expected to interact weakly with normal matter. They are a popular candidate because they could potentially be detected through their weak interactions, and their predicted properties align with some observations related to dark matter. However, direct detection experiments had not fully detected WIMPs, but if they exist, they could potentially make up a significant portion of dark matter. Axions are very light, neutral particles that were initially proposed to solve certain problems in quantum chromodynamics. They are also considered a dark matter candidate due to their properties. To this day, axions are still being actively searched for in experiments. Machos, also known as massive compact halo objects, are massive celestial objects such as black holes or neutron stars that do not emit light. While machos can contribute to dark matter, they are not that closely related to dark matter. Neutrons, neutrinos are subatomic particles with extremely weak interactions with matter. Sterile neutrinos are hypothetical heavier counterparts that do not interact through the weak nuclear force. Some studies have suggested that sterile neutrinos might contribute to dark matter. Last up, gravitinos. These are supersymmetric partners of the graviton, predicted by certain theories like supersymmetry. If supersymmetry is correct, gravitinos could be stable and contribute to dark matter. While these candidates seem intriguing, none of them have been definitively confirmed as the dark matter particle. Experiments still continue to try and detect or rule out these various candidates, and the search for dark matter remains an active area of research in astrophysics and particle physics. Fun facts about dark matter. Dark matter is invisible, but shapes the universe through its gravitational influence. We know dark matter exists, but its exact makeup, particles, or new physics laws is still unknown. Dark matter can create cosmic rings by bending light around massive galaxies. Theories suggest dark matter might include ancient black holes formed in the early universe. Scientists turn dark matter experiment data into audible frequencies, creating unique sounds. October 31st is celebrated internationally to raise awareness about dark matter. Despite years of study, dark matter remains a persistent mystery, driving ongoing scientific exploration. Here's a quick video to recap what I have said.
Dark matter is the stuff that makes it possible for galaxies to exist. When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex structures. Stars would more likely be scattered all over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby, so we know there's something there that interacts with gravity. Right now, we have more ideas about what dark energy is not than what it is.
Okay, and here are my references, and that's the end of the video. Thank you for watching.